Good day, everyone. We are the group number 2, and our experiment is amplitude shift keying ASK, modulator and demodulator. We are the presenter, Wilson Eschumeres, Kirby De Guzman, and Jester Dale David. What is ASK? Amplitude shift keying ASK is a type of amplitude modulation which represent the binary data in the form of variation in the amplitude of a signal. Yung ASK po, AM din po siya. Binabago po niya yung amplitude ng carrier depende sa digital input. Like AM and ASK is also linear and sensitive to atmospheric noise, distortion, propagation, condition on different routes in PSTN, etc. Dahil nga po AM po yung ASK, susceptible po siya sa noise. Reliant po siya, kasi yung ASK sa amplitude ng signal. Kaya po pag sa transmission, malaki po yung effect ng noise. Then both ASK modulator and demodulation process are relatively inexpensive. The ASK technique is also commonly used to transmit digital data over optical fiber. For LED transmitters, binary 1 is represented by a short pulse of light and binary 0 by the absence of light. Simple lang po, yung construction ng modulation at demodulation ng ASK. Maganda po yung ASK pag yung transmission po ay sa optical fiber. Wala pong masyadong noise sa optical fiber. Then next. The simplest and most common form of ASKs operates as a switch using the presence of carrier wave to indicate a binary 1 and its absent to indicate a binary 0. This type of modulation is called on and off keying or OOK. And it's used to at radio frequencies transmit Morse code referred as to continuous wave of operation. The experiment used OOK is a modulator to produce an ASK signal. Yung on and off po na keying po yung pinakasimple na ASA. Yung carrier po ng on and off po depende sa binary signal. Yun po yung gagamitin sa experiment po. Then next is the setup of the experiment. The following components are used in this experiment. 1-piece transistor BC107, 1-piece each resistor 4.7K, 10K, 2.2K, 1K, and 10K path. 1-piece capacitor 0.01 microfarad, 1-piece diode 1N4001, 2 pieces Cedar diode 5Z1, 1-piece operational amplifier IC741, 2-piece signal generator, and 3 pieces oscilloscope CRO. Then 1-piece power supply, positive, negative 15 volts, 50 millivolts. Then the next presenter is Kirby De Guzman, will be present ASK modulation circuit.
Good day. My report will be ASK modulator circuit. Next. The ASK modulator circuit used in this experiment is set up in the following manner. So ayan po yung ginawa po naming circuit na nakabase po sa experiment po namin. Yung pong the 5 kHz carrier signal is connected to the collector of transistor with a series of resistance 4.7 kiloohms. Square wave signal generator is connected to the base of the transistor as the input digital signal. A series resistor 10 kiloohms is connected to the signal generator. The output is connected to the collector of the transistor. The ASK modulator used in the experiment is just a simple circuit consisting of a transistor. The transistor function as a switch. So yung pong BJT transistor, nag-act lang po siya na parang switch. When the input binary signal is high, the transistor conducts and the ASK output becomes 0 volts. When the input binary signal is low, the transistor becomes as an open voltage, which outputs the carrier signal. Oh. Yung input binary, kapag po yung input binary is high, the transistor will be active. Yung collector and emitter magiging short. Kaya yung output magiging 0 volts. Pag low naman yung input binary signal, yung transistor nagiging open. Yung carrier signal dadaan sa collector, kaya nagkakaroon ng output. Next slide. The ASK modulator outputs of the following signal. Ayan po yung output niya. Just the will show so yung para makita yung output, gagamit ng oscilloscope. Ko-connect sa collector and emitter. Pag niran, tapos magkikita yung signal. Ayan po yung output signal niya. Pag-ibalik po sa PowerPoint. So ayun po, kaya ayun po yung output carrier signal po niya. The signal produced is an on-off or OOK signal. The carrier that is being cut off when the binary signal is high. This is the simplest analog form of ASK. So kaya tinawag na on and off, yung carrier signal meron siyang stable high at stable low. So ganun po siya, meron siyang stable high at stable low, kaya tinawag na on-off keying. Gumagana lang siya na parang switch, kaya tinawag ito na simplest form of ASK. So ganun lang po. The next reporter will be Jester Del David that will report ASK demodulator circuit.
Good day everyone. I'm Jester Del David and I will discuss about ASK demodulator circuit. So the ASK demodulator circuit used in this experiment is the following. The demodulator consists of a diode as a rectifier. The ASK input will be rectified by this diode, and then it will be detected by this envelope detector, which consists of a capacitor and a resistor in parallel. Then the output of that envelope detector is connected to the comparator, which compares it to the to a reference voltage. If the output of the envelope detector is higher than the reference voltage, the comparator will output a negative 15 volts, which will be regulated by the Zener diode pair into a negative 5 volts. Here is the circuit in the multisim. This is the output of the demodulator signal, the demodulator circuit. So the demodulated signal is close but not exactly the same to the original digital signal. As you can see, the voltage level on the of the outputted demodulated signal, uh, it doesn't stay on the 5 volts, which is the input signal used in this experiment. For comparison, here is the original input signal. So the original input signals jumps from negative 5 volts to a 5 volts, but in the demodulated signal jumps from around 5.5 millivolts to a negative 5.5 millivolts. So one reason that the demodulated signal isn't exactly the same as the original signal is because the signal, the ASK input passes through different components of the demodulated circuit. For example, the diode and the envelope detector and the operational amplifier. Another reason that the demodulated signal is not exactly as the input signal is because of interference of different signals in the component. So because the ASK relies on the amplitude of the signal, the component can have different effects on it, which can produce a signal that is uh, higher, a little bit higher compared to the original signal. But the difference is just small and can be polished by the use of filters. So this is the comparison of the original signal against the demodulated signal. Here the original signal is in channel A and the demodulated signal is in channel B. Here you can see that the original signal is 5 volts, but the voltage in channel B, which is the demodulated signal, is negative, is 5.5 volts. So the conclusion of our experiment is that ASK modulation is a modulating technique that changes the amplitude of the carrier frequency in accordance to the input binary signal, much like an AM technique. So here we will take a look at the output of the digital of the ASK modulator on off. Here we can see that the ASK is just the on-off ASK is just the carrier signal, but the amplitude of the ASK signal is cut off when the signal generator square wave is in high. Let's connect the two. Here we can see that if the input signal is in high, there is no presence of the carrier signal. And this is a type of AM. It modulates or it transforms the amplitude of the carrier signal in accordance to the input of the uh, to the modulated signal. So next conclusion is that ASK modulation and demodulation can be constructed easily. This experiment only used a transistor as the main component in the modulation, while the demodulation is constructed using a simple envelope detector, a comparator with a Zener diode voltage limiter. Here we can see that the modulating circuit is just a transistor which acts as a switch. If the input binary signal is high, then it will become shorted, which then the output of the ASK will be a 0 volts. And the demodulator signal is just a rectifier, a envelope detector, a comparator, and a voltage regulator. And the ASK modulation is susceptible to noise because it relies on the amplitude of the carrier signal. So as we saw in the results, the demodulated signal isn't exactly the same compared to the original signal. This is because of the different components in the demodulator circuits, and different elements such as atmospheric noise can play a big part can affect the ASK signal uh, greatly. So that's it for our report and for the timeline of this experiment. Week 1, we did the assigning and research. Then the following week, we did the gathering of resources. And in week 3, we set up the experiment, the presentation, documentation, and we also analyzed the results of the experiment within that week. Then in the week 4 is the finalizing of our data. So the this experiment is done by group 2. The presenters are me, David Jester Delgi, De Guzman, Kirby, Ramirez Wilson. And the programming, in charge of the programming is Ariel Sikat. Then in charge of the documentation is Malyari Mark Ivan and Lopez Daranjay. And that's it for our video presentation. Thank you very much.